In this video, we're going to look at a new definition for continuity at a point. So in dealing with limits, we learned that polynomials are really nice because all we have to do to evaluate the limit of a polynomial is just plug in a value. And it's kind of a nice property that we wish happened more often. So we're going to give it a name and a definition for the types of places where valuing the limit is just the same as plugging in the value. All right, and this function is known as continuous. So your function is continuous at this point A, so x equals A, if all three of the following are true. First of all, your function value has to exist. Second, your limit has to exist. And if they both exist, then they're equal to each other. So in essence, it could really just be the third step, that your function value and your limit equal each other, because they can't equal each other if they don't exist. All right, but these two things exist and they're equal means that your function is continuous. And that basically means evaluating the limit is the same as just plugging in your value, just like a polynomial. All right. If any of these are untrue or multiple are untrue, we call our function discontinuous. All right, so discontinuous means it's not continuous. All right, so verify that this function is continuous at 1. So the first thing we need to do is figure out, does f of 1 exist? All right, f of 1 means I plug in 1 into my function. Get 1 minus 4 over 1 minus 2. Negative 3 over negative 1, I get positive 3. All right, so my function value does exist. Second step, my limit exists. So does my limit as x approaches 1 of fx exist? Well, let's check it. All right, when we're evaluating a limit, the first thing we always try to do is plug in our value. So if I plug in 1, what happens? 1 squared minus 4 over 1 minus 2. And that's negative 3 over negative 1 is positive 3. Right? So nothing goes wrong. This is fine. And you can see I get 3 for both of these. So this one is continuous. The function value exists, it's 3. The limit value exists, it's 3. And since those two are equal, the function is continuous at x equals 1. All right, and the following graph is it continuous at x equals 2. So x equals 2 is here. So let's look at our function value. With our function value, we go to the spot on my graph, figure out the dot, and figure out the y value. So f of 2 is 3. Now let's look at the limit. The limit as x approaches 2 of fx. For the limit, we look at the space around that value. So now we're looking at kind of this strip of values. And we're looking at that strip of values. They all hit the same y values around here. And those y values are at 3. All right, so is this function continuous at x equals 2? The answer is yes, because the function value exists and it's the same as the limit. So yes, it is continuous. What about at negative 8? So first let's focus on the function value at negative 8. We go directly to negative 8 and we go to the dot on my graph, and that happens at negative 3. So f of 8 is negative 3. What about the limit as x approaches negative 8? Oops, that's infinity, negative 8. All right, for the limit, we're not focused on the value itself. We're focused on around that value. So I'm focused on this kind of region around negative 8. And you see for that region around negative 8, I have this u down here, and all those y values are getting close to negative 6. So my limit exists, and it's negative 6. So part 1 is right, my function value exists. Part 2 is right, my limit exists, but part 3 does not exist. Negative 3 is not equal to negative 6, so my function is not continuous. All right, so that's just something you have to do. Sometimes both happen, but they're not continuous. All right, the way I remember if a function is continuous is you're going to draw it without lifting up your pencil. So in that previous example, at 2, I had this kind of smooth line I could draw and not lift up my pencil, and that ended up being continuous. At negative 8, I had to draw this loop down, lift up my pencil to draw that little circle, lift up my pencil to continue it, lift up my pencil to draw that little dot. All this lifting up of your pencil means it's not smooth and continuous. So if you can just draw this thing without lifting up your pencil, all that's going to be continuous. But as soon as I start having asymptotes and I start having to draw little circles by lifting up my pencil, and I start having weird jumps and stuff, that's where you're going to be not continuous. right, so here's the important things. All right, you're going to have to know the definition of continuity. All right, it's basically just a memorization thing of remembering these 3 points. But remember, it's related to polynomials that we want our limit value to be as easy as just plugging in the number. All right, so that third rule is really the most important, that the limit value and the function value are equal. All right, for now, you can verify continuity by plugging in the value and evaluating the limit, and then see if they agree. All right, so this is the kind of introduction to continuity.